Scientists have discovered the first ever white hole after years of conjecture, so stay tuned as we bring you the scientific discovery of the first ever white hole. Black holes, scary huge phenomena hiding in the deep space and eating anything that comes close, are presumably familiar to you. A white hole, on the other hand, is the polar opposite of a black hole. Take notice of the descriptions, since many of them apply to white holes as well, albeit in the opposite direction. Black holes are available in a variety of sizes, but there are three primary sorts. The mass and dimensions of a black hole define its kind. Primordial black holes are the tiniest of them. This form of black hole, according to scientists, is as little as a single atom, yet has the mass of a massive mountain. Stellar black holes are the most prevalent sort of medium-sized black hole. A stellar black hole's mass can be up to 20 times that of the Sun, yet it is still rather tiny. The enormous gravitational pull they exert on other objects is because of the high mass concentration. Scientists believe that the Milky Way galaxy has hundreds of star-mass black holes. Supermassive black holes are the biggest black holes in the universe. There are almost 1 million suns in all. They would, however, fit inside a box with a diameter about equal to that of the solar system. According to scientific data, every huge galaxy has a supermassive black hole in its center. Sagittarius A is the name given to the supermassive black hole at the center of the Milky Way galaxy. It has a mass of around 4 million suns and is small enough to fit within a ball the size of the Sun. What is the origin of black holes? Primordial black holes are theorized to have originated shortly after the Big Bang in the early universe. When the core of a big star collapses in on itself, it creates a stellar black hole. This collapse also results in a supernova, or exploding star, in which a portion of the star is blasted into space. Scientists believe that supermassive black holes developed at the same time as the galaxy in which they are found. The size of a supermassive black hole is proportional to the size and mass of the galaxy in which it exists. A black hole is invisible because its enormous gravity prevents even light from escaping. Scientists, on the other hand, can see the impact of its high gravity on the stars and make educated assumptions about it. If it is around a certain location in space, high-energy light is created when a black hole and a star orbit near together. This high-energy light may be seen by scientific equipment. When a black hole's gravity is powerful enough, it may draw away a star's outer gases and form an accretion disk around itself. As gas from the accretion disk spirals towards the black hole, it warms up to extremely high temperatures and emits X-rays in all directions. The X-ray light is measured by NASA telescopes. This information is used by astronomers to understand more about the characteristics of a black hole. White holes are the result of this. The polar opposite of a black hole is a white hole. In actuality, it's a black hole seen in the past. As previously stated, once material hits the event horizon of a black hole, it is doomed and unable to escape its powerful gravitational attraction. A white hole, on the other hand, is an area where space-time rushes inexorably outward. It is reported to have an event horizon radius which prevents any stuff, even light, from entering. The white hole is thought to radiate light with a force comparable to that of a black hole. The sheer force of the gamma rays would annihilate them and their spacecraft if a foolish crew attempted to enter a white hole. Even if the spacecraft were sturdy enough to resist that much energy, space-time around the white hole is constructed in such a way that the amount of acceleration necessary to go inside increases as you get closer. To summarize, entering a white hole needs more energy than the entire universe. As a result, you may as well give up. As you might expect, the notion of white holes was discovered as a result of a mathematical obsession with black holes. Albert Einstein realized in 1905 that, whereas accelerating viewers see time differently, non-accelerating observers do not. Those who are traveling at a constant speed or who are immobile and who believe that the speed of light is unaffected by motion. Later, Einstein presented his general theory of relativity, concluding that things with mass have gravity, which is a distortion of time and space rather than a physical force. Carla Schwarzschild would then solve Einstein's field equations to determine the equation of mass in vacuum space-time or in an environment where matter is avoided. The Schwarzschild metric was born as a result of this, which we will not go into detail about because the equation is quite complicated, but in basic terms, it is a mathematical depiction of a black hole. Schwarzschild had devised an equation for a black hole that was fully static, with no charge or change. This is an exterior black hole that has always existed and does not alter in size. Keep in mind that all occurrences occur infinitely distant in the future, at or beyond the event horizon. As a result, these occurrences appear to have never occurred to an outside observer. The Schwarzschild metric demonstrates that in an idealized black hole, space becomes time and time becomes space, changing roles so that the black hole's singularity is at some unavoidably future time rather than a place. We glimpse a dying star when we go back in time in a genuine black hole. When an endless black hole is reversed, however, we get a white hole. However, not all scientists think that white holes exist, making the current discovery more noteworthy. Why do some scientists deny the existence of white holes? While they assert that simply because white hole and beige general relativity are theoretically correct, this does not imply that they are practical. This is why some scientists have dubbed white holes an impossible possibility, implying that while they cannot be ruled out entirely, they are unlikely to be discovered by telescopes. They base their argument on the fact that this event defies the second rule of thermodynamics, which states that the universe's entropy must either remain constant or grow. Entropy is sometimes referred to as chaos, although it is more accurately defined as a growth in the number of potential states for particles in a given system. Black holes are particularly good at this because they take stuff with low entropy and disseminate it across enormous areas over time, producing space chaos. White holes that add matter break this rule, since they reduce total entropy. This is also why scientists contend that time cannot be reversed. This does not rule out the possibility of white holes. Due to the limits of space-time, renowned theoretical physicist Carlo Rovelli proposed that if black holes could no longer evaporate and shrink, they would undergo quantum bounce or an outward pressure and transition into white holes. This means that when black holes arise, they virtually instantaneously turn into white holes. However, due to gravity's time dilation, we continue to view a black hole for billions of years as outside observers. If this hypothesis is correct, black holes that originated in the early years of the universe might be on the verge of dying and bursting into cosmic rays or another kind of radiation at any time. In 2006, NASA's SWIFT satellite discovered an unusually intense gamma-ray burst known as GRB 060614 in a weird part of the sky. These bursts are normally classified as either short or long bursts that are usually connected with a supernova, although GRB 060614 did not fit into either category. It lasted a whopping 102 seconds but had nothing to do with a stellar explosion. In comparison, most gamma-ray bursts last only 230 seconds. GRB 060614 happened in a galaxy with a small number of stars capable of exploding or bursting into extended bursts. Astronomers and astrophysicists believe the gamma-ray burst sprang out of nowhere and folded in on itself after only a few minutes. Scientists propose the theory that GRB 060614 might have been a white hole a few years later. How did they arrive at this decision? It's because GRB 060614 exactly portrays what a white hole should look like. The fact that present scientific theories offer no alternative explanation for what happened strengthens this argument. They explain why they believe white holes exist. Having said that, that's it for now. Thank you for watching the video. If you liked the video, then don't forget to press that thumbs up button and also that hot red subscribe button as well. We'll see you in the next video. Until then, peace.